Hello students. So today we will look at the project assignment that I have given you. So I will walk through the design and the demo so that it can help some of you. So we'll be having the demo in two parts. In the first part we will talk about the REST services, and in the second part we will focus on the microservices. So let's begin with that, and just excuse me for this getup. So I have to tie that. So please excuse me with that, and with that let me switch off the video. Okay, so the video is switched off, and let's move ahead now with the project assignment. So first let us understand what we are trying to do in this project, right? It's a small project, it's not a very big project, but still it's an entire system. Starting from the front end, there's a website which is in the front end, and it goes through the middlewares. You can say this is your middleware: customer REST service, account REST service, money transfer service, and there is another service over here. So they have been connected to in some ways, and there's a backend which is consisting of all the databases. So we see 4 databases over here: customer database, account database, money transfer database, and this is some event synchronizer. Okay, so and there is a gateway over here, we see, right? So what are these components? So definitely this looks like some kind of a banking website. In the banking website we have customers, we have accounts. It is not necessary that every customer is opening an account. Customer may go to a bank, maybe he just wants to transfer the money, right? So not necessary it is associated with the account of the bank. It depends on the bank. If the bank has a rule that you need to have an account to transfer money to any other bank, then maybe that condition will apply. But so we are trying to create a small banking website where we have customers, where we have accounts, and where we have money transfer. So ideally the architecture would be something like a 3-tier client architecture, but in this case we are focused on, we are seeing a client server architecture where this is the client, and this is this is supposed to be your server, my bank API gateway, customer REST service. Everything is supposed to be a backend server side, and we have a 3rd tier which is a database, which is customer database, account database, and money transfer database. And so ideally in a 3-tier client architecture there are only 3 components. One is the website, one is your entire system, and one is your single database. In that single database you will have customer data as well as accounts data as well as money transfer data. So it is but in this diagram you are seeing that one single database has been split into 3 different databases: customer database, account database, and money transfer database. Because not only we are implementing a client server architecture in this, but we are also implementing a service oriented computing architecture, service oriented architecture, and we are also at the same time implementing microservices architecture. So what is service oriented architecture? It is a architecture where the entire system is based on services. So in this case we are seeing 5 services: My bank API gateway is supposed to be a service, and in the same way customer service, account service, money transfer service, and event synchronizer service. So we are looking at 5 different services, and so that's why all these services, they are working with each other. Now my bank API gateway is a service which is a single point of contact for any service. If you notice from the website, if I come, I have to contact the API gateway first, and then only I can reach through the API gateway. I can reach the customer REST service. Implementation wise, it would mean I call a REST service of API gateway, and so a particular function will be called, and inside that function the API gateway will make a decision which service to call in the backend. So the services, at least the customer REST service, account REST service, money transfer REST service, my bank API gateway, they are all behind the server. If they are behind the server, which means you cannot access it, it is more secure, and so nobody knows what internally how it has been implemented. So from security perspective, it is good, and so that is why it is service oriented architecture. And it is microservices architecture is where we have split our one system into 3 systems actually. So customer system, account system, and money transfer system. Each system has its own database and its own service. So and it has all its data in this system. In the same way, accounts has its own database and own service. It doesn't need customer REST service. So services are not talking to each other, but you don't see a connection point between them, you see. So that is what, so these systems are independent. So what does that mean? Now that means, let's say a bank, this is running on one local host, particular port number or a particular machine, then this is running on some other port, some other machine. In the same way, this is running on some other port and or some other machine. If one service, let's say, stops working for some reason, and this goes this fails down, it is not working, this connection is failing, does that mean this connection will fail? No, because this service is implemented independent of this service. There is no connection between this service and this service. So, and that is the advantage of a microservices architecture. Each service is a system in itself, where it has all the data for itself. It has all the business logic embedded inside this service. It doesn't require any other account. If the customer REST service goes down, it means that only the customer's operations will fail. Which means, like, let's say I want to add a new customer, then it will go through this link and try to create a customer. It will fail if this REST service is not working. But does that mean some account holder cannot come here and create a new account in this service? No, account creation process will keep going on, and at the same time money transfers will be going on. Now, and so the advantage is your other services don't stop just because one service has stopped. So that's why in this microservices architecture we are having 3 microservices. There are 5 REST, where we are thinking of 5 services, which is API gateway, customer, account for money transfer, event synchronizer. But there are 3 microservices, and 3, which are the 3? This is customer REST service. You can say customer service, don't say it REST. You have account service and you have money transfer service. This is the entire one system. So there are 3 microservices. Now the thing is, some accounts will be connected to some customer, but there is no connection between account and customer. So how does the account knows which account is belonging to which customer? So it goes in the database, it can find all the accounts but not the customer data. This is where the event synchronizer REST service is used. Every time a new customer is added or there is some operation happening over here, this service will contact the event synchronizer REST service with the whatever changes have been happened. So you see this gray line. So this gray line is basically coming in, and an event has been notified over here. So what does this REST service will do? It will note down the event and mark the event as open status, which means I need to do something. So what it needs to do, it basically tries to duplicate some of all the not all, but whatever is important for the account system. It takes that data and passes it over here, and that is what you're seeing, this gray line, which pulls the data if necessary. But this line is something which we are going to avoid in our implementation later, because it is not good for the service to access database directly. It is better that this line goes through the REST service and let the REST service take the data and give it back. So that would be a better architecture. One should not give direct access to databases except for one point. So we will look at that later, because we are not focusing on microservices, we are focusing on REST services. So so this event synchronizer is basically, if there is an event on customer, like create a customer, delete a customer, it will notify the event by calling it service, and this service will then go and inform account REST service and money transfer service that such and such event has happened on the customer. If you want to store the data by yourself, do it. If you don't need the data, ignore it. So you can, so essentially event synchronizer is synchronizing any events that is happening across any of the services in the microservice system. So that is what this architecture is. It has got three architectures going on in the system, which is client server architecture. Specifically, this is a 3-tier. There are many tiers in this. There are not only 3 tiers. There is one tier which is a website. Second tier is a API gateway. The third tier is your customer REST service. The fourth tier is your databases, right? And then there's a fifth tier which is event synchronizer REST service, and there's a sixth tier which is event synchronizer database. So there are around 6 tiers in this system. Okay, so just let me hold on. Okay, so that is what the architecture is, and that is how the system is working. So let's now look into the implementation part. So we'll focus today on a customer REST service, how it is implemented, right? So we'll look at that. So where is practical SOA? Okay. So this is my root folder, SOA. So I have created my entire project inside this folder. So this folder contains all my HTML pages, and it has all the necessary JavaScript files. Now if you notice, my API gateway has been implemented using AngularJS. Now which means AngularJS runs in the browser. It is not running on the server, it is running on the client side. So that if you look at the diagram, I am expecting actually the bank API gateway to be a REST service. So but I thought it will get it will be little difficult to understand what is happening in case if I implement this as a REST service on the server side. So what I have done is I've taken this API gateway and the architecture is still the same, except that this implementation has been done using AngularJS inside your website. Okay, so you notice I've used AngularJS in this. So this is AngularJS code, which is a JavaScript code, and but AngularJS is nothing but JavaScript, where lot of functionalities has been implemented for you, and it is kept ready. It helps you create a application very easily by using the MVC architecture. So there is a MVC architecture in play over here as well. Okay, so that's the difference, where the API gateway has been shifted to the client side. Otherwise, the rest of them are REST services. So let's look at the REST service. So that is my bank website. It has a page, customer page, right? So let's just click on the customer page, and what do you see? So you see I've created one simple customer page, and which has name, address, phone, type, right? If you go, the menu has customer accounts, money transfer. So it is a single website, but I am connecting using the gateway to the different REST services depending on which system I want to talk to. If I want to talk to customer system, then I will call the customer REST service. If I'm connecting to accounts system, so if I click on accounts, you will not find anything because I have not created anything. The purpose of this demo is to show you how this customer REST service has been implemented. In the same, just like customer REST service is implemented, you need to implement the accounts REST service, as well as you need to implement the money transfer REST services. So in the customer, you see we have name, address, phone, and type. So there are actually 5 columns, but if you use accounts, in accounts you may have account ID and account name, and maybe another table for customers, so that you can decide how your database will be. And in the money transfer, usually you will have the source account and the destination account. So and you will have the source account is the account where the money is coming from, and the destination account is where the money is going. In the accounts, actually I remember there will be one more column which is account balance. So every time money is been taken out of the account, the balance should reduce over here, right? So if you look at the diagram, let's say somebody transfers of money over here from X account to Y account, so that money will be transferred, but then it will inform the event synchronizer that I have transferred the money from so and so account to so and so account. This event REST service will then go ahead and call the account REST service and say so much money has been reduced in your account, and so please reduce the balance. So in which case the REST service will then go ahead and reduce the balance in its own account database. So do you see there is a how services are talking to each other. So this is an example of service choreography. What API gateway is doing is service orchestration. What the rest of the services they are doing mostly is it is doing service service choreography. So those so in two ways you can your service orchestration is where all the other services dependent on one service. In this case, services are not really dependent on each other. They are little independent, and there is a choreography going on between all the 4 services. Right? So So let's so that was my bank website. So this is your home page which we just saw, right? So this is my home page, and this is a very simple HTML page. And let's view source. Can we view source? No, we can't view the source over here, so we'll use Notepad++ for that later. But before that, before we look into the website, this is my database, right? So in this I have this folder called SQL script data. So see, when I'm implementing, I had to decide which language I'm going to use to implement. So my website is implemented using HTML, and right now it is only HTML. So I've used HTML to create my website, but not necessary it is a website. It can be a mobile app also, or you can have two different applications. One is a mobile app and one is a website, but both of them will use my bank API gateway. So the website is implemented in HTML. My bank API gateway is implemented in AngularJS. That's what I mentioned, right? Then these three services are implemented using Jersey REST services in Java. The databases have been implemented in MySQL. So those are the tools which I am using to create my system. You can choose your own system or your own language to implement this. It doesn't matter. The important thing is the business system should work as per the business rules. The architecture should work as per the architectural rules. If you want to implement this in PHP, that's fine, you can implement it in PHP. If you want to use React.js over here, that's fine. Now my bank API gateway could have been implemented in Node.js, and the advantage of using Node.js is it uses JavaScript and it runs on the server, and the moment it runs on the server, it is more secure. The code is not visible to anyone. But we have not used Node.js in this architecture. We have used AngularJS because right now at this stage I am more comfortable with AngularJS. Node.js is something I have not worked on too much, but ideally if in a real world I would have gone with Node.js for my API gateway, because it is easier to code in Node.js, as well as it is more secure to implement services in Node.js compared to AngularJS. And if you're using Java, then all the more good, because Java is also a good language of choice when you want to implement, because Java has a lot of libraries where you can do a lot of operations. Okay, so yeah, so what is this SQL script? This is basically I'm creating all my tables, so I'm creating my customer table in this case. So what is in the customer table? Let's look at it, right? Let's open it in Notepad++. Where it is? Oh, it's opening up. So you see I'm creating two rows, Anuradha, London, and so this is the account name, customer name, customer address, customer phone number, and customer type. So I'm defaulted to 0. So let me create, so this is your SQL script. So you need to know how to write SQL script. right? So in the SQL script you are creating the database, right? So you're creating the DB customer database, then you're opening the database, then you're creating a table, and the primary key is underscore ID, and the columns are name, address, phone type, and these fields are to keep track of what is happening at what time and date. So whenever the new record is created, it will the creation date should be here, so that we know which customer was created at what time. Whenever the data is modified, this last modified date should be updated, so that we know when was the last time the customer data was updated. Created by records the user who has modified this data, and not modified, who the user who has created this data, and last modified by is the last person who has modified it. In this case, now I'm defaulting it to sys. It means the system, because this records are going to be created automatically initially, so that's why I'm saying it is created by system. But ideally this will be some username, whoever is creating the customers. And then you see what I'm doing is I'm loading the data. I'm reading the file which you just saw, tcustomer.csv. that is the file just now you saw over here. It has two records, and I'm loading so these files, since I'm using MySQL Server 8.0, this is the way you need to load it. The whatever data you need to load, it has to exist in uploads folder. Now if you try to search for that folder, it will not exist because it is hidden. So let's see if I can show you this quickly. So it's open, right? So let's I need to remove that extra slash because I am in Windows Explorer. Okay, I can see the uploads folder, but I think it is usually hidden. Oh sorry, in C:, yeah, this is what I was saying. If you notice, you cannot see program data in this, but actually program data is hidden. If you type it, it is hidden on purpose. What is the folder name? Oh, it's no spaces. So okay, so where am I? Oh, it's closed, the Windows Explorer. Okay, let me go back again. Oh, it's here. Yeah, so if you notice, program data cannot be seen here, right, because it's hidden. But if you type it, it will appear. And then basically this folder is a hidden folder. It is created by systems are using it to manage your data, and it doesn't want to show you that folders. Okay, so it's a hidden folder, and you need to study a little bit about how to load data in MySQL. So this is the way, and I'm using a CSV file to load two records into table tcustomer, and it will be stored in 4 columns, right? The other columns will we are not passing because we are defaulting it to now, which is the current date and time, and the last 2 columns we are defaulting it to sys. So let me now, what is this group concat max len? This is setting the limit to the amount of data that can travel between MySQL and your client. If you look at the diagram, this red line, it says on this line, if somebody fires a query, so customer service says select star from customer. So if I want to get all the customers, the maximum amount of I think it's the bytes, not the bits. So maximum amount of bytes that can be passed in a single query is this number. So sometimes if there are a lot of records that is going to be accessed, then you should make sure this number is above that limit. So how do we load the data? I'm going to use what is it called, MySQL Workbench, right? That is the tool we are going to use to load the data. So I open the Workbench. Okay, so let me go to the Workbench, right? So database, let me connect to the database. So let me open the file. So where is the file? Right, this is the query. This is the Workbench, right? Yeah. So let me drag and oops, it doesn't open. Let me go back to the Workbench. So here is the SQL, right? So let me close the other files, it can be confusing, don't save. Right, so this is the same file which I have opened in the Workbench, and I'm going to run this against the MySQL database. Yes, so I execute, and what do I see? Where are the results? Oh, see, the results are here. So you see all the queries have been fired, and in the end you see 2 rows have been created. So if I want to verify, I will say use db customer, select star from t customer. So if this database is created, then this records should be there, right? Now I fire these queries. So you see 2 records have been created, Anuradha and Palak. And if you notice, I defaulted to the date and time to be current date and time, so it has stored the current date and time, which is 2:52 in the night. And this is sys and sys, right? So your database is ready with 2 dummy records. It is a kind of a test records, you can say, and we will play with these records actually. And so in the diagram so far, what we have seen is we have created customer database so far, and you also saw my banking website. You saw 2 pages, customer page. You saw actually only 1 page, which is the customer page. The main page basically contains only the links to all the other 3 pages, but customer page is what you had seen. Accounts page is not there. Money transfer page is not there as of now. So so that is what this my bank database is. I am using the SQL scripts, and I've created a common database component which anyone can use to connect to SQL server. So we will so we see what is this is a program which is a common code, and it has basically one function called execute query, right, in which you need to send the query string and query type, and it will go ahead and connect to your database. So your database name, username, password is you access it from this file dbconfig.json, which this function initialize database is called in the constructor, which means whenever you're going to create this object, it is going to initialize the database, and in that initialize database function it is going to read the JSON file and fetch the database name. So if you notice what is there in dbconfig.json, I have stored the database name, database username, database password, and this is just a test query, but this three rows are important to connect to the database. So if you want to connect to a different database, or your username password changes, you you open this file and modify it over here, and automatically the program dbSQL. So where is dbSQL? So dbSQL will read that data and execute the query against that database. So that is what that is how your customer database has been implemented, along with one small Java code, JDatabase. So then you have customer REST service. So let's see customer REST service. So that is what my bank database is. You saw my bank database, you saw my bank website. Now you're going to in this website you also saw your website pages, which is customer page. So in case if you want to create an account page, you will copy this and you will make this accounts page, something like this, right? And then you will go and modify this page to reflect accounts page. Most of the things will remain same. So my bank customer will become my bank accounts. I'm just showing you a very high level some things will not be the same. Wherever is customer ID, you change it to account ID, right? Replace all, and wherever there is customer, you change it to account or accounts, whatever name you can choose. This is just I'm showing you quickly how to create your another web page, and you'll have to understand how this works, because this is using ng-click, and it is a part of AngularJS. It means whenever you click this button, you call this function select query. Then it tries to locate that select query based on who is the controller. So if you notice, my API gateway controller is implemented in my bank API gateway.js. So if you open my bank API gateway, this is my gateway. We spoke about it. We said it is implemented in AngularJS. Now this program will be the center point, or maybe a common point to access any services. So in this case I'm accessing customer service, you see customer. So just like there is scope data.customer, and this is a common gateway, I need to have something similar. So in this case it will be accounts, something like this. Table name will be account T account. Now I have not created an account table as of now, but it will be something similar. Then I will have my fields will be account name, right? I'm going to use small case since I'm using small case in the customer, and I said I need to have account balance. Ideally I would need an address, but I will not store the address to the account. I will just store these two columns. It will have an ID field, and then wherever this is a customer name, so this will become account name, and this will be account name again. This will be account balance, right? And this will be account balance, right? And I don't need the other columns in accounts, so I'm going to have only two columns. So what you're noticing is API gateway is through this page I'm going to call the REST services. And how I'm calling the REST service? So as I said, when somebody clicks a select query, the select query function is called. So so if you notice, I've implemented select query function down in AngularJS, and this is very specific to customer services. So the four crude operations, they are connecting first to, they are going through the API gateway, and then the API gateway will decide where is the REST service and how to access that REST service. So select query, what it is doing, it is initializing the query, and then in the end, once it has initialized everything, it is executing the query. So if you notice, it is customer dot execute query, it is data dot customer dot select query. So you need to have similar functions, which is scope dot data dot account dot select query. In the same way, for money transfer, you should have scope dot data dot money transfer dot select query. So there are four operations for any database, and I've implemented them for customer. You should implement them for the other two services. And what is happening in execute query? If you notice, execute query, my customer will be running on port number 8081, and my other two services, which is accounts and money transfer, I have not implemented, but they will be running on a different port. You cannot have the same port for two services. They have to run on a unique port. So if this is 8081, accounts will be running on 8082, and money transfer can run on 8083. So it is connecting to 8081. So now if you look at the diagram, what I have shown you is a API gateway where the query is executed, and it is connecting to the service on port number 8081, which will be running over here. I have not shown you this component as yet. We will look at it, but it is running on 8081. Now this gateway, it is implemented in AngularJS. Okay, so so this gateway is implemented using AngularJS, and in this gateway it is running on the browser, and every time the website wants to access the REST service, it will first call the AngularJS function, and there will be separate functions, but all the functions for all the REST services, it will be there in the API gateway. So through this gateway, if it is a customer request from the customer page, it will connect to 8081. If it is coming from accounts page, it will go through gateway to 8082. So let's look at this. So you see the execute query, it is connecting to 8081. It will so what is this service doing? This service will be actually connecting to that DB SQL component, so let's look at the service now. So where is this service? Yeah, so this is a bank website, and this is your My Bank Jersey service. So you notice there are 4 different services. I've created a separate folder for each of these services, and I have not implemented accounts. So customer is what I've implemented. You need to have these folders: src, target, and pom file. Within that you need to have main and test folder. Within main folder you need to have Java resources. In Java, this is your code begins. So my package name is My Bank, and this is your normal REST service that we have implemented in our labs. And let's have a look at it. Right, so this is the service which we had created in the lab, in our practicals in the last semester. So if you notice, it is going to be running on 8081. So if I am going to create, let's say for example, I'm creating an accounts service, the best way is to copy this, then go to accounts, paste it here. Then the only thing that will change is wherever there is customer, you will have so in this there is customer, right? So you change it to account, and MySQL is common, JSON is common, database component is common. Anything else? Do you see customer? Yeah. So my bank dot, this is your main class. So right now we have we just opened main customer, the Java code, but you need to have main account class. So the package name is My Bank. So whenever your service is running, it will look out for the main function in main account. Right, so this is all the modification you require in pom.xml. So remember, this is residing in accounts folder. I'm just showing you a quickest. Target is something, the files will be created automatically, so you can delete this file whenever you compile. These files are going to get created automatically. Source code is what is important. So main Java, so this is a package name My Bank, this is your main customer which is in accounts folder, so this should change to main account, right? And this is your actual service, account service, so in this case this will change to account. Now I need to do the similar modification inside both the Java files. Wherever there is customer, I need to shift it to account. SVC customer will become SVC account. DB SQL is a common object, so we let it remain the same. So SVC customer again here will become account. again. So remember, we are creating a accounts REST service, that's why we are changing this. Okay, and this page will be, so you want to, this is my bank account service. So you notice this is a simple get function, get REST service. And then we have a post service, and this is the link execute query. So whenever somebody calls an execute query, this function is going to get called, and internally what happens? Internally it will try to connect to the database and call execute query, and we have already seen what is happening in execute query. It will connect to the database and it will fetch you the data, right? Okay, so do you see customer in this anywhere? Okay, do you see customer now? So you need to make sure your code is correct, otherwise you will get errors. Do you see customer anywhere now? No, I can't find any. Customer means all the customer text has been replaced with accounts. So this code, so you have created your account service, and inside this file main account I have not made the changes. So remember, this is a main class which we just had modified in the pom.xml file. We mentioned over here what is the main class. So in this case it is main account, and so the main class will be main account, and as I told you, accounts will run on different ports. So this will be 82. Okay, I don't think there is any other changes. So in the main account.java, right? So whenever main account will start, it will open up on port number 82, not 81. So the API gateway will connect to this service on port number 82. Okay, so this was just to show you how to quickly create the service. We are not going to test account service, but we are going to test my bank service customer. So we are going to test customer service now. So let me close all the files. It's too many files are open, and let me just focus on customer files, which is pom.xml. Let's see what is there inside this. So you see the customer, it's the name is my bank customer REST service, and this is my bank dot main customer. If it is account, it is main account. If it is a customer, it is main customer. Okay, so now so what all we have seen so far? We have seen a customer REST service, we saw an API gateway, we also saw a customer database, and then I showed you how to create another service in another folder In this case we had created an account REST service, and we did not create account database. We have to, just like there is a SQL script for customer database, you need to create a SQL script for account database. So so everything, how to create a REST service and its database, everything remains, the process remains the same. Right, so we are going to click on customer page over here, then the customer page will come up, and there are 4 functions on that page, the 4 crude functions, which is going to call a function in API gateway, and inside this API gateway it is going to connect to the REST service, and this REST service is going to connect to the database and give me back the data. So this is what we are going to test now. So before I do that, I want to show you how to compile. So first I showed you so far how to load the data in the SQL database. If you want to compile J database, so the way you can compile J database, the J stands for my name so that I know that this is my component. So let me go to that folder. So I am inside command was wrong, 1 second. Right, so I am in my bank database folder, right, and inside this I have a J database, and inside the J database is a package name, and there is a class, and so let's delete these 2 class files. So I delete, and I'm going to compile it again. Right, so the class file is connected. So now this 2 Java file is there, which we need to compile. So I have, if you open dbsql.java, I have given you a sample command how to compile. You see this? So let's compile. No, I need this one, the second one. Yeah. So let me compile my core Java. So I'm going to compile J database. So you notice Java C. These are the jar file I'm using, and this is my package name, and these are my Java files inside that folder. So I run the compile command, and it will create the class files. So now if I look inside, 2 files have been created. Now since I'm using Maven, I need to make sure this class file is stored in the Maven repository. So I'm going to give you a small, I've already explained this in the class, but I am going to explain a little bit on Maven again. Right, so I had a folder called J database, and then I had star.java. Then I ran the compile command, and then I saw class files. Right, now you need to take all the class files and you need to create one zip file, which will be in the .jar format. Then I need to take this jar file and store it in Maven repository folder. Right, so I showed you how to create a class file. Now I am going to show you how to create a jar file. So all the commands you should find in this there's a Maven commands. So I have stored some useful commands for you to for reference purpose. where is there a jar command here? Yeah. So you see I'm creating jdatabase.jar, and it will include if you notice, this is jdatabase.star.class, means it is going to take this file and put it inside your jar file. It is going to take json simple.jar and put it inside your jar file. Whatever file you specify after this command, all this is going to be packed just like a zip file and stored in jdatabase.jar. So let us run this command. Right. So you see it has created all the files, and now if you notice your where are we here, bank database, there is a file created at 3:22 a.m. which is 3:22 a.m. It has been created just now. This is jdatabase.jar file. So that is how you create a jar file. Now we, as I mentioned, we need to store it in a Maven repository folder. Now Maven repository folder is a common folder. So this is some folder on your hard disk. If you search somewhere in C:, this folder will be there. So we need to make sure that this file now goes in is stored in this folder. So let's see how to store in Maven repository folder. What is the command? So again we look at Maven commands, right? So this is the command maven mvn space install : install. So okay, this is installing MySQL connector jar. Let me the command. If you notice, I have created a batch file. This will, if I run this batch file, it will going to store all the jar files inside the Maven repository folder. How do we open? Can I open from here? Yeah, I can open from here. So this is test jdatabase.bat file. So if you go through these commands, I am doing compilation automatically. This command you already saw. Then the next command that I run is jarring, which happens automatically. Then I am installing MySQL connector Java into Maven repository. So this is another jar file that we need to store. Then I am storing JSON simple jar file inside the repository, and in the end I am installing the jdatabase jar file. So this is the command. It starts from here and it ends over here. So I created this batch file because every time I am doing modification I have to execute all these commands. So instead of executing each command at a time, I store them in a batch file and I run the batch file in one go. It does everything. So we are going to look at that also. And So we are going to run the Maven command. So if you notice, Maven command is going to take jdatabase.jar file, and this is a Maven install, which means it is going to install it in the Maven repository folder. Oh, why it's taking time? Yeah, so it has gone ahead and it is saying it is installing jdatabase.jar to which folder? c:users.m2 repository mysql. So this is the folder. If you want to know which is a Maven repository folder, this is the folder. Okay, if you open this folder, right, system is low. I think battery is down, so I need to put the plug-in. If you open this Maven repository, this is a Maven repository folder. It's a repository. You see a lot of files are there. MySQL 8 connector will be here, and so there are a lot of, so I think we had created JDatabase, right? Where was JDatabase? Okay, I stored it in MySQL JDatabase 1.0. So you see my jar file is residing over here. So whenever any if I run any program using Maven, and if I want to call a function of JDatabase, it will create the object using the class which is stored in the jar file, which is in the Maven repository. So I'll explain you that further, but just the important thing is we have taken this jar file and put it in the Maven folder. So now the next step is I want to now run my REST service, right? So where is my REST service? So this is what about JDatabase and compilation. I have shown you everything in this section. Now we'll go to REST service. This is my customer service. If you notice now pom.xml file. So now notice we have from in the diagram, let's see, I showed you only the customer database and JDatabase component which is stored in the Maven repository. Now from the customer REST service, I need to connect to the database using the JDatabase component. So how does that happen? So all that you specify in your pom.xml, give all the information where your files are. So if you notice, I would have registered my JDatabase over here, right, and MySQL. So using this for the same folder that you saw in the Maven repository. Is that right? Yeah. So we saw the same folder in the Maven repository, and there the jar file was existing. So give me a minute. Okay. So all your dependency, if you're dependent on any jar file, you need to store it in the Maven repository, and whichever application, in this case it is the REST service application, you need to go in the pom.xml file and specify where to find this particular package. So now if where is my diagram? Here. So what we have shown you, this was all this left hand side was there in the JDatabase folder, Then we shifted ourselves to customer folder. This is where our REST service is. Then in this I had a pom.xml file. Inside the pom.xml file I had mentioned where my J database is. So whenever I am creating a class in J database, it will go in the repository folder and fetch it from here. You see. So in this customer I have two files that I created. I had main customer, which basically will start the service on port number 8081, and my service is implemented in SVC customer. In this I have one post function. The function name is execute query. Right, so this is how your service is connected. Then I created on the, I've already shown you the website, and with this I had customer.html file, which will call underscore bank API gateway dot js. This is what we saw. In this, if the user is wants to read customer, it will say, a function will be called, which is customer.select query. And in that select query, what will be called? Customer.execute query. And in this execute query, what will happen? You will see a function which will look like http it is not exact, but it will be something like connect to 8081, right? And then it will say 8081 / execute query. So this is how your website has been constructed. So this 8081 is running where? Is running over here. It will come here, and this execute query has been implemented in this function, right? This function will then will try to search for J database, and it will find that it is there over in this repository, and then it will instantiate the database to connect to the database. I've already shown you the code of J database. It connects to the database. It will take the data and pass it back to through the gateway to the HTML page. So this is how the entire flow is working, right? So I am going to save this diagram in the folder where Maven commands are, so that it is easier for you. I'm going to in fact upload all this to some common place where you can access it from. Code execution flow. So where were we? So we were on the REST service, right? So let's so this is the Maven repository. Okay, let me go back to my REST service. It is inside customer. Okay, so I just want to rename this accounts to account, because everywhere I'm using account, right? Customer. Now the question is, how do we compile? I can delete the classes. I can compile them. So how do we compile? the way we compile is we go to the folder where pom.xml is. This is the folder. So notice I'm compiling only the customer REST service. I am not compiling account REST service. That application is in a separate folder. So let us clear the screen first, CLS. Now let us go to the folder. Okay, so now I am inside my customer folder and pom.xml file is here. So inside the source folder I have all my source code, and the command is mvn clean compile. So this is going to compile my code. If there are any errors, it will show it over here. If there are no errors, you will see build success. And once it is compiled, then once I am compiled, the target folder should contain all the class files, main.customer.cals class and svc customer.class file. So now everything is compiled. I can start my REST service. So now my website is also running on 8081 right now, but I need to make it run on a different port. So just not to confuse you, I'll keep the code as it is, because we are focusing more on the REST service. So let's start the REST service. But what I wanted to tell you is this folder is not useful, not required. If you look at the main customer dot, I'm running my I'm running my website by adding this, right? I'm adding the folder my bank website. This is where my HTML pages are. So my website is also running at the same time on port number 8081. But this code should be there in a separate file. It should not be running on the same port number. It should be running on different port number. The website should be running on different port number, and the REST service should be running on a different port number. In this case, both of them are running on 8081, just for the ease of understanding. So later I may modify this part of the code. So now that I've compiled, I start my REST service. So this will start my website as well as my REST service. So the way we do it is mvn exec : Java. So this will start the program main customer.java, and if you notice, it is running. And now if you look at the service, so let's close this. Let's open a blank window. So this is the link, application WADL. So you notice two functions have been exposed: get function and execute query function, right? So now I am going to, my website is also running here, so I'm going to run customer my bank .html. So the page comes up, it is running on port 8081. Accounts page is not been created, so I'm going to click customer, and this is just the bottom section is just debug information. Whatever query has been fired, I displayed over here so that I know what query has been gone back to the database. It is just used for testing purpose. So now I read what all records have been created in the database. So remember, we created 2 records. So when I click on read, it is executing. Oh, it is not working. I modified the code, right? So just hold on.